minimize another option I have in SolidCAM so that I don't have to create another operation for this side as well. So we'll close the operation itself. And note we have a small box over here with an R in it. This is an option that I use for rotating the operation. If I were to open up my option of transform, you can see that I used rotate angle list. If I were to open it up, you can see I have my first angle at 0 degrees, exactly where it is right now. And my second just rotated around my home position 180 degrees. If I were to take a look at my entire simulation, my entire toolpath now, just by clicking over here, you'll see that I'll have a toolpath on both sides. Even though I didn't create an operation on the second side, I just used the transform option to do the operation on the other side. Now, in my next operation, I'd like to deal with these surfaces over here, which is a radius around the part over here. Now, this radius actually is going around the entire part as well. However, I'm only going to do the HSS in this area. As in this area, I'll use later on with a radius tool, actually just do a simple profile operation over there. I can't do that over here because then that particular tool will actually go into this surface over here, which is not called for. So I'll start this operation, and if we take a look, again, I'll be using this time morph between two boundary curves, as shown over here. My geometry, again, will be the surfaces that I need on top over here. And if I go into my start edge will be the top edge of that radius as shown over there. And the end edge will be the bottom one. Again, I'll be using a ball end mill, the same one I did use before. And again, we have my toolpath parameters, this time a smaller step over of 0.1 millimeters, because this is a very small surface over here. If I were to take a look at the simulation, you see it's working around this area over here. Now, it also did the other side, because again, just like in the previous operation, I also have it using the option of transform rotate. Now, in the next operation, I'd like to deal with this surface over here. And just as in the other case where I did these operations, I also did the ones on the other side by transform. I'll do the same on this surface as well, being machined with the transform of this operation that I'm about to do right now. Now, this particular operation, this is actually a flat surface. But the problem over here is that by using a regular end mill, I cannot get to that corner as is required by this particular part. So again, I'll use the option of HSS, but this time I'm just going to have it go parallel to this edge, working on the surface. If I were to open up the operation itself, I've used the option of parallel to curves, as shown over here. My geometry of my drive face is that face over there. And my edge curve, as I've mentioned, is this edge over here. Again, I'll be using a 10 millimeter ball end mill, and I have my toolpath parameters set over here. Now, let's go into my link. Now, in this particular case, I have a gap between the toolpath that's going to actually happen between this edge and to this edge as it's going across the surface over here. There's a gap over there. So what I'm going to do in this particular case, in my link for the large gaps, I'm going to have it go direct. However, I don't want it to go straight ahead into it, as there's a lot of material over here. I'd rather actually come in from a little bit of a radius on top. So what I've done here is I've chosen the option of large gaps direct, but I've also added the option of use lead in and lead out in this particular case. If I were to take a look at my lead in and lead out, you'll note that I'm going to be coming in with a vertical tangent, coming in from the top with an arc movement, but I don't need a complete 90 degrees arc. 45 degrees of an arc is enough. And I don't need 100% of my arc diameter. 50% in this particular case was enough for me as well. If I were to take a look at the simulation, you'll see, and I'll zoom in to the toolpath itself, you can see that it's going directly across to the other side. However, it's first leaving the material over here with an arc, then going across, and then when it gets to the other side, goes back down just above the area where we have the material left over. And that's how it works across this area. And as I mentioned before, it's working on both sides of the part because, again, I use the option of rotate within my transform option. Now, what's left to do as far as HSS goes on this part itself are two areas. One, this radius around the bottom of this edge over here, as well as these chamfers inside over here as well. So in my first operation, I'm going to use morph between two boundary curves where my geometry is going to be these surfaces as shown over here, and my start edge will be the one on top, and my end edge will be the one at the very bottom. Again, I'll be using my 10mm ball end mill, and I've set my toolpath parameters as well. Taking a look at the simulation, you'll see, and I'll do this slow, the tool actually goes down, working its way across on the part itself, completing that entire radius. Notice this radius is difficult because this radius starts from a large surface to a very, very small surface in the corner. But this is easily handled by HSS. And note again, I use the transform option of rotate on the part to do it exactly the same on the other side instead of creating another operation. Now I've done the same for my next operation for those chamfers. If I were to open it up just for a moment, again using the same option, geometries in this case is this surface around over there. We have our start edge, our end edge, and of course we have our 10mm ball end mill using the exact parameters that I had in my previous operation. Running my simulation, you can see that it works exactly on those edges as well as the one on the other side, again because of the option of transform. The next operations, I've used the regular 2.5D operations to finish off the rest of the part. Now let me just go into the particular one that I've created for these radiuses around the edge over here. I'll open up the operation. I use a simple profile operation using the geometry of this edge going around up until this edge over here, as well as another edge over here, as well as the inside edge over here. And in this case, I used a shape tool that has this radius as shown over here, which is the exact radius that's needed for that particular radius that I have on the part itself. If I were to run my simulation of that operation, and this time I'll use the solid verify option to simulate the part, you can see that my tool will go down. And let's just take a quick close look at the edge itself and the tool. You'll see that we have the tool with the radius going down and completing the radius on the part itself as shown over here. Now the rest of the part, we have our drilling operation for these holes over here, as well as the thread milling for those holes as well, and a chamfer on the top of the holes. So this entire part was machined by collaboration of HSR, profiling and pocketing and drilling operations, and would not be complete without the use of HSS. For more videos on SolidCAM Professor, please go to our website www.solidcam.com and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.